Hi guys, in this video we'll learn about concurrency. Concurrency is the main feature of the Golang. Go language is concurrent language, not parallel one. So first we need to understand what is the difference between concurrency and the parallel. So over here guys, parallel means suppose if something task is going on, parallelly we can run one more task. Or you can say suppose one task is running on one thread, another task is running on another thread. Or I can say this is core 1, this is core 2. One thing is downloading on this particular core of my processor, another thing is downloading or running on this one. So suppose this is downloading and this is rendering. Concurrency means the thing is happening over here and after that one more concurrent task is going on, then again the same task, then again, then this task and then this. So concurrent means we are doing the two tasks concurrently, means one by one. So few time is spent over there, then after that switch, it will actually rendering, then again downloading, then again rendering. So Go language is concurrent language, not a parallel language. Okay. Some language we have the parallel also, they are downloading and they're doing with the two different thread, or we can open the multiple thread also. Over here in the thread itself we have the small you can say goroutine we called, and there is an n number of goroutine we can open it, and these goroutine is actually will work simultaneously. So parallelism is not a always faster thing. This is because the component running in the parallel might have to communicate with each other. For example, in case of the browser, when file is downloading is complete, this should be communicated to the user, say using a pop-up. This file is downloaded successfully. The communication happened between the component responsible for the downloading and the component responsible for the rendering the user interface. This communication overhead is low in the concurrent system. In this case, when component run in the parallel, multiple core, the communication overhead is very high. Hence, parallel programming don't always result in the faster execution. Concurrency, in another way, concurrency means when two or more tasks can start or run, or I can say complete, in overlapping time period. It does not necessarily they will actually start on the same time. Over here in concurrency means time slicing. It's virtually doing in the parallelism, but actually things is happening into time slice. In simple example, suppose right now I'm teaching you also and writing down something also. So that meaning I'm actually teaching, I'm actually explaining something, and I'm taking the another actually task, I'm pausing it, and I'm actually switching the task, or I'm just slicing it. That concept we called concurrency. Another example, I'm actually writing also and I'm listening music also. That means we are doing the two tasks parallelism. So Go language is working on the concurrency. Now hope we understand what is the meaning of concurrency and parallelism. In Go language, concurrency handled by goroutine and channels. Channels we use basically data, or we can say communication between the goroutines. Now what is a goroutine? In Go language, goroutine is a function or method that run concurrently with the other function or method. Goroutine can be thought of as, you can say, lightweight thread. The cost of the creating of goroutine is very tiny as comparison to thread. This is very lightweight and we can actually open a number of goroutine also. Let's see the practical guys. Over here I'm making a main functions. In main functions, let's write down one print statement. Main functions fmt.println ending main functions. In between we call one function that is called hello. This hello function is simple functions hello, and just simply write down some message over here. We need to make a goroutine. I'm just simply write down in front of it go. Let's run it. Now we can see we got a main function and ending the main functions. We never see this one. Remember guys, when a new goroutine started, the goroutine call return immediately. Unlike the functions, the control does not wait for goroutine to fix the executions. The control return immediately to the next line of the code after goroutine called, and any return value from the goroutine also will ignored. Right now it does not have return value, but if we have return value also, that is also ignored. So this goroutine is never wait, it need to complete it, because the reason is main function is also goroutine. The main function is goroutine and this will run and execution is done inside in it and it will return it. So main goroutine should be running by any other goroutine to run. If the main goroutine terminate, then the program will be terminated and no other goroutine will run. So guys, we need to stop the main program. Right now, to stop the main program, I'm using the timeout only. Over here, we will actually 1 second pause. So we know that in the 1 second, definitely this will be execution will be done. So we can see hello world is coming, and that is coming from the goroutine. Okay. So we need to be just pause the main thread, or you can say the main goroutine. Okay. So this is the way we will work. But later on we want to use the time one. We will use the channel or either the wait group. Let's see another example. Suppose we have the two functions. One is to writing down the number, another one is to write down the alphabet. So these are the two functions. Over here I wanted to be just every time it will run a loop and it will actually pause for 250 millisecond. Over here 400 millisecond. It will pause it. So these are the two goroutine, and these two goroutine will call it over here. Here also I need to pause it the main thread. Otherwise main thread is never work it, because it will call it and it immediately will return it back. So we'll see. Let's run it. This one, guys. So I need to run goroutine 1. Over here we can see ending of the main function. So I need to pause the main thread also. So I know this is the time is actually 400 and 250. So I'm just giving the tentative time the bigger than this one. So I'm writing down 3000 seconds over here. When I run, I can see these goroutine is working one by one. This one work, it will print. Then it will switch it over here. It will print this one. Then it switch it over here. This will like it. So this is actually the meaning of the concurrently. So goroutine is working the behind the scene is like a way. The one task of this function, other task of this functions, and like it will switching between them. And this is super lightweight, guys, as comparison to thread all. We'll see this one also if we'll do the more actually, you can say more complex problem we'll see, then we will see this one also. So over here, the main goroutine will wait 3000 milliseconds. Now, what is the channel? Channel can be, you can thought like as a pipe. Channel means it is something we wanted to through the pipe. So goroutine will be communicated through the channel. So we will send something from one side of the pipe and it will receive from another side of the pipe. Channel we use for just making the synchronizations between the thread. Suppose I wanted to wait it particular thread should be completed, then I need to do something else. Then I can use the channel also. So through the channel, guys, we can receive the data also. So that's it, guys. In this application, we understand goroutine is working concurrent, not as a parallelism. In Go language, if you need to be work as a concurrently, I need to be the main thread should be the, you can say wait also, otherwise it will return immediately. Goroutine we need to make through the go keyword. To communicate between the goroutine, we need to be take the help of the channel that will achieve the synchronization task also, and it is working as a collection also. That thing I will explain into the next video. Till the time you guys can do the practice and understand the Go concurrency. Thank you, guys. Thanks for watching the video. Have a nice day. See you in the next video. Thank you.